Students, this is Unit 3, Triangles, the lesson 3.3, something called Triangle Guts. Triangle Guts. Remember, you want to record the location, the date and time that you're watching this video, as well as make sure you get a parent or guardian sign-off. This is a recap of our previous lesson here. I want you to go ahead, pause the video, find all possible angle measures, and then restart the video. Pause, do, restart. Welcome back. Students, did you actually pause the video and do this on your own? If you didn't actually pause the video and do this on your own, you're short-circuiting your learning experience. It's very important you learn to take the initiative, do the work on your own, and then check it. So hopefully this is a welcome back after you actually pause the video. Our goal is to find everything possible. So you start with the simple stuff, like the fact that we have vertical angles here, so 46. And then we know triangles add up to 180. So in the margin, I'm going to add 84 and 46. And I get 130. I'm going to take that away from 180. Of course, we get 50. That means this angle up here is 50. Hopefully you notice the fact that this is a 90-degree angle. That means up here, 50 from 90, this is 40 degrees. So now I'm going to add 85 plus 40. I get 125. I take 125 away from 180. And I get 55 degrees. That means out here is 55 degrees. You think you're done, but careful, watch out for these exterior angles there. That's 180. So we're going to do 180 minus 46. And we get 134 here and 134 there. You think you're done? Watch out. If I say all angles, I mean all angles, my friend. Because right there, lo and behold, we have another linear pair, which means this angle on the outside, 84 from 180, is 96. Now you're done. Go back and see if you managed to get all the angles there. Okay, for this lesson, when I mean triangle guts, guts is a slang term for the insides of a person. For the inside of a person. And there's going to be lots of new terminology today. You're really going to need a ruler, and I highly recommend some colors. Here's our new terminology today. Something called a median, centroid, altitude, orthocenter, perpendicular bisector, circumcenter, angle bisector, incenter, and a vertex. Now I'd like you to go back and circle the ones you've never heard before. Circle the ones you've absolutely never heard before. I'm going to be looking for that when I grade this. Let's do some basic terms here, basic terms. Get out your straight edge, please. In all of these, there's always three. I'm only going to show you one. A median. In the margin, just write this. A median is a segment, these are all segments, which goes from a triangle corner to opposite midpoint. So darken a corner, find an opposite midpoint. That's a median. An altitude always goes from a triangle corner to a right angle on the opposite side. An altitude, triangle corner, right angle on the opposite side. That's an altitude. Triangle corner, right angle opposite side. Triangle corner, right angle opposite side. That's an altitude. Two more. Perpendicular bisector is exactly what it sounds like it's doing. It's perpendicular and bisects the side. So if you find the midpoint of a side, that gets you your bisector, and you draw a line through it, right angle, that is a perpendicular bisector. Notice it doesn't have to go through the corner. It just cuts a side in half and makes a right angle. And the last triangle gut is an angle bisector. So if you sweep an angle, now your eyeball's not on the side here, it's on the angle, and you cut that angle in half. And when you do an angle bisector, always go through the side. So you de-emphasize the side. Your eyeballs are here. That's an angle bisector. So here's your four triangle guts in a simple summary. A median, an altitude, a perpendicular bisector, and an angle bisector. Now we're going to look at these in detail. We're going to create three medians now. We're going to do a quick sketch them. Let's fill out what is a median. A median is a segment which connects triangle corner to the opposite side. Triangle corner to the opposite side, specifically the midpoint. You have to be connecting a midpoint if you're doing a median. Midpoint creates a median. So step one, we're just going to eyeball the midpoints here. Just eyeball the midpoints. That's one. Hatch mark. Remember, no hatch marks, no midpoint. Just eyeball that midpoint. Eyeball this midpoint. I'm going to pause for a second and let you catch up. Now we're going to draw three medians here. Ready? Darken corner, midpoint. That's one. Say it out loud as you draw it. Ready? Corner, line up your straight edge. Corner goes to the midpoint. Corner, line up your straight edge. Midpoint. Now you have three medians. Label just one of them. This is a median. They're all medians. All three medians intersect at a single point. That's called a centroid. The medians intersect at a centroid. The way I remember this, medians, centroid, MC, like an MC of a theater show, or MC Hammer, if you even know who he is. Medians intersect at the centroid. An altitude is a segment which goes from a triangle corner to a right angle on the opposite side. A triangle corner to a right angle on the opposite side. Let me show you. So it always starts from a triangle corner, and it goes not to the midpoint. It makes a right angle with the opposite side. That is an altitude. Corner, right angle, opposite side. Corner, right angle, opposite side. That's an altitude. Let's draw a couple more altitudes here. I'm going to switch colors so it's easier for you to see them a bit. And remember, you're not aiming for the midpoint right now. This is not a median. Use your straight edge. Your goal is to get right angles with the opposite side. And try to draw this to scale. That's one right there. That's another altitude. Corner, right angle, opposite side. Notice I have 3 right angles. 1, 2, 3. That altitude, that crosses, that's not a centroid. The altitudes cross at what's called the orthocenter. Orthocenter. So the altitudes cross at the orthocenter. Students, I paused the video here because I was trying to find a YouTube video. There's lots of ways you can remember this. AO, orthocenter, goes with the altitude, but when I hear AO, I hear this song ringing in my head. A little past your generation, I'm going to try to pull up a YouTube, see if you can get it. But when you see altitude orthocenter, I'd like you to repeat after me. Say it nice and loud. AO, AO. Ready? Do it again. I know you think I'm crazy. Try it again. Ready? You're saying A and O. In a moment, you'll know where this comes from. A-O, A-O. No clue where that's from. I'm going to try to pull up the YouTube. Hopefully this records. If you're curious, that's called the Day-O song by Harry Belafonte. You can look it up. And the start songs with a nice and loud A-O. All that to say altitude and orthocenter. Let's pick up the pace here. Now, when you do altitudes, there are some key things you need to remember about an altitude. When you have an acute triangle, the altitudes, let's draw them real quick. Altitudes, ready? Corner, right angle. Corner, right angle. Corner, right angle. Zip through with your ruler and draw all three altitudes. In an acute triangle, all three altitudes are inside the triangle. Inside the triangle. Therefore, the orthocenter is inside the triangle. In a right triangle, remember we're going to corner and right angle. One altitude is inside, so corner, right angle. So in a right triangle, you have one that's inside, and then you have two altitudes. Again, corner, right angle, corner, right angle, corner, right angle. You have two altitudes which are on the triangle for a right triangle. One's in, two's on. That's for a right triangle. For an obtuse triangle, things get really interesting. For an obtuse triangle, we have one altitude which is inside. So corner, right angle. Now it's impossible to get another corner and right angle either inside or on. So what you do is we're going to extend this side, extend, and when we extend it, you dash it. And that means this altitude, corner, right angle to the opposite side, is actually outside of the triangle. That's one. Again, extend the side. Corner. Right angle. So in an obtuse triangle, you have one altitude that's in and two that are actually outside of the triangle. So let's recap. When you're dealing with altitudes, acute, all three are in. Right, one's in, two's on. Obtuse, one's in, two's out. Perpendicular bisectors. When you have a perpendicular bisector, it simply is perpendicular and bisects a side. Has nothing to do with the triangle corners. That's very important. So because we're bisecting a side, you start with the midpoints again. But you're not aiming for the corners. So you have your midpoints, and then you simply draw a segment that's at right angles through that midpoint. That's one. And the right angle is at the side. That's two. That's a right angle. Three, right angle. Those perpendicular bisectors cross. This point here is called the circumcenter. You won't understand, that word circum means go around, and in class we're going to do a little experiment that explains that. The in-center, when you have an angle bisector, it bisects the angle corners. Bisect the angle corners. This is the one, your eyeballs are not on the sides at all. They're on the angles. So sweep all three angles. Your goal is to cut each of those angles in half. So watch carefully. I want to cut this angle in half. So when I draw my angle bisectors, your eyeball's not on the side, it's on the angle. So I like to take the segment through the side, so it tells my brain, forget the side. So that's hatch marks. Ready? We're going to cut this angle in half. We're just free sketching it. There's a more accurate way of doing this. We're going to do this in class. And again, you're bisecting the angle. Your eyeball is not on the side at all. Those three bisectors, they intersect at what's called the in-center. The way I remember this one, the circumcenter goes with the perpendicular bisectors. I think perpendicular bisectors, circumcenter, PC computers. The angle bisectors go with the in-center, AI, like artificial intelligence. And we're going to focus on one, specifically the centroid. So in the diagram below, we're going to mark the midpoint of LM. The midpoint of L to M is going to be point R. The midpoint of MN is going to be S. And the midpoint of NL is going to be T. Now we're going to draw in our three medians. There's one median. There's two medians. There's three medians. Darken your centroid. Now I need you to do something. Put your pencil down. And I want you to finger pinch, please. Finger pinch. I want you to finger pinch this segment right here from the midpoint to the centroid, and I want you to compare it to this segment right here, centroid to the vertex. Finger pinch. Put your fingers here, and then compare it to the distance here. Do it the same for all three. Midpoint to centroid, finger pinch this, compare it to this distance here. Again, midpoint to centroid, finger pinch that distance, and then finger pinch from here to here. Please finger pinch and compare the distances from the yellow to the orange on each same segment. You're going to notice a pattern. Go all the way around with your fingers pinching, please. You should have noticed something. This orange segment is twice the yellow all the way around. If you pinch that carefully, you should feel that the orange is all the way around. The orange is double the yellow. And this is true only of the median. So we learned that when you have a median, They intersect at the centroid. So let's do a quick sketch of medians. That's the centroid. That the segment to the centroid is twice as long as the centroid to the midpoint. So from the vertex to the centroid, that's always going to be double of centroid to the midpoint. So this is a 2x and x relationship. From the vertex to the centroid is always going to be twice as big as centroid to the midpoint. So let's trace this. A to G is twice of G to D. So A to G is 2 of G to D in this diagram. G to C, if you trace G to C is going to be twice of G to F. Trace E to G, that's going to be twice of G to B. So there's a 2x and x relationship all the way around. Ready? Let's do a couple. Below we have all three are medians, so hatch marks, hatch marks, hatch marks. All three are medians, which makes this point here N the centroid. And if J to N is 8, we want to find N to M, question mark. We're going to do a thing first equation, which is simply this. The fact that J to N has to be 2 of N to M. So if 8 equals 2 times NM, if I want to find NM, I simply divide by 2, and of course, this is 4. I'll do one more with you. Right here, it says if H all the way to K is 24, we want to find H to N alone. Now, careful. This takes a little bit of doing here, because what we know is that this is a 2x and x relationship. We know HK is equal to HN plus NK. And HK is, the whole thing is 24. H to N is a 2x and NK is our x relationship. So you solve. So we have 3x equals 24. Divide by 3. And x equals 8. So NK is 8 and H to N is 16. So H to N would be 16 here. I want you to pause the video and take a shot at this completely on your own and then restart the video, knowing that what you see here, that this point right here is a centroid. Make sure you do a thing equation before you solve. Pause, solve, check. All right, I'm going to color code this for you. WK, I'm going to do this in orange. WK is the whole thing. F to K is, I'm going to keep blue, F to K is right here. Now, there's a little piece missing. We know that this segment here, the purple, which is WF, is twice as big. So we actually have two relationships here. We have to get WF equals 2 of F to K. You need to write that down first. That's the purple. WF equals 2 of FK. That's one thing equation. That's true. Your other thing equation is the fact that WK equals WF plus F to K. There's your other thing equation. To solve for X, we're going to circle, plug, chug here very carefully. Ready? Very carefully. WK is up here. So we have X plus 3 equals WF. We have no WF up here, but we do know WF equals 2 of FK. So I'm going to go 2 times -7 plus X. That's WF plus FK, which is -7 plus X. Now we solve. We have X plus 3. This is going to be -14 plus 2X minus 7 plus X. You should collect like terms. X plus 3 equals -21 plus 3X. Our goal is to get X on one side and our numbers on the other. So I'm going to minus X. I end up with 3 equals -21. That's going to be plus 2X. Add 21. I end up with 24 equals 2X. Divide by 2. I get X equals 12. Careful, you're not done. You only solve for X. Now we come in and we plug it up. WK, that means this is going to be 12 plus 3. That equals 15. If you put in a 12 here, -7 plus 12 equals +5. So that means this is 5. That's 10. And this whole thing is 15. There's your check. It fits.